Howdy, howdy, this is Mr. Potter. What we're going to do in today's video is talk about our Unit 4 performance task. The idea here is that we're going to be making a drawing of our own on a sheet of graph paper, collecting data points from that, and using those data points to make our turtle follow the exact same path. In other words, the turtle will be reproducing our drawing using the coordinates that we find. So the first thing that I want to talk about is how I get this graph paper. And I've got this URL for you if you don't have the graph paper. If you go to tinyurl.com/csp-graph, and I'll show you what that looks like. So if we go to that page and hit enter, then here's our graph paper. And you can download this. This is from my Google Drive. I've got a website down here that I was able to print it off on it, and I'll put that website in the description. But the idea is once you do that, you're going to make some type of drawing. And what I've done here is I've just written MistaPotta in cursive on my graph paper, slightly askew. That's just because of the way that I scanned it. But the idea is that we're going to use this drawing to collect points. So we're going to have to find X and Y coordinates of points on this graph. And because we're using graph paper, it's going to be fairly easy to do so. So what I did is I went ahead and let this point right here be my origin. So this is where X is equal to 0, and this is where Y is equal to 0. And then what I looked for is I looked for what I've got here. I let each one of these spaces be 5 points. So this line represents X is 50, and this line represents X is 100. And if I use that same scale up here, then this vertical line right here is going to be positive 25 in the Y direction. This line right here will be negative 25 in the Y direction. And then what I did is I started off with my first point, which is 0, 0. And then every time I crossed a line, I figured out what the coordinates of that point is. And I'm estimating it here. I'm on this X line, so X is 5, and Y is about 3. So I called this point 5, 3. And then I went to the next time I crossed the line, which is right here where I'm crossing this horizontal line. So because my Y is 5, my X is about 8. So I had 8, 5. And then I went to the next time I crossed the line, which is about right here, which is about the point 10, 7. And I continued with this technique, following the path of my signature, the path of my drawing, as I went through every line that I crossed. But also keep in mind, like a place like this where I'm not necessarily crossing a line, but that's the high point. I'm not necessarily crossing a line, but that's my low point. I have to keep track of those points as well. And I made a list of data points. And if I go to my Google Docs, of course, this is my scanning that I came up with, and you can see those same X and Y coordinates that I talked about. But this is my data points. You'll notice that I have two different columns here. These are my X coordinates up here, and these are my Y coordinates. And the reason that I've separated them is because I'm going to make them separate lists in Python. So I'm going to have an X list and I'm going to have a Y list. And we're going to be using an idea very similar to how we did the two lists at one time program, the day 2 program in Unit 4. So here is my Sculpt program, and I'm going to go ahead and get rid of everything that I've got. And I'm going to start with my comment. So remember, the first thing that we're supposed to do is identify what's going on. So this is my performance task. Performance task code. And I'm going to put my name, so MistaPotta. And then this is period 7, because my computer science class this year is 7th period. And then I'm ready to put in, to create the turtle. So I'm going to say import turtle, and T gets turtle.Turtle. So I've created a turtle object after I've imported from the turtle libraries. And now I'm ready to take care of my data collection, which means now I'm going to copy the data that I collected. I'm going to highlight all of this. I'm going to right click and copy it. Then I'm going to go back to my Sculpt, and I'm going to paste it. And it's going to be long. Notice that it does go off the side of the page, and that's fine. I have 122 points here. You should have at least 100 points in order to have a fine detailed graph. But what I'm going to do at the beginning of this line is I'm going to say X gets, and I'm going to open the bracket. And at the very end of this line of code, after this last data point, I'm going to close off that square bracket. I'm going to do the same thing for this line of code. So I'm going to say Y gets, and I'm going to open a square bracket, and then I'm going to scroll all the way to the right and make sure that I close that square bracket. And I'm going to get rid of all the lines, the blank lines that I had here, because those really are two sets of data that go with each other, the X and Y coordinates, as I go through my drawing. So now that I've got my X and Y coordinates in here, now I need to move my turtle to the starting position. And the idea is that if I'm going to move my turtle to the starting position, I want him to not draw. So I need to make sure that my turtle has its pen up before I move it to its first location, which means I want to move to the first X coordinate and the first Y coordinate. So I'm going to tell my turtle to set position to the first X coordinate, which is X bracket 0, the first element of that X list, comma, and then Y bracket 0, the first element of my Y list. And then once it's in that position, I'm going to tell my turtle to set its pen down. So at this point now, my turtle is at the very first position. So now I'm ready for my turtle to go through this list of data with its pen down. So it will actually be drawing this stuff. So I'm going to set up a loop. So for index in, and I want this to be the range of the length of list X. And I put a colon here. Remember, the colon makes it a loop. Make sure that everything is indented. But notice that X and Y both have the same length. So it doesn't matter if I use X or Y in this case. Either one will work. And then inside the loop, notice everything that's offset by 4 spaces is going to be repeated. I'm going to tell it to set its position to X sub index, comma, Y sub index. And the idea is that it's going to go from 0.00 to 0.11 to the second X and second Y, to the third X and third Y, the fourth X and fourth Y. Finally, it'll come down to the 122nd X and the 122nd Y. And that will be the end of this loop. So once I get to the end of this loop, this that we've done right here, this is actually tracing the drawing using our data points. So once I've done that, now what I need to do is I need to do one last thing, and that's to hide the turtle so it doesn't obscure the drawing. Because remember that whenever we're drawing, we see the turtle on the paper, but I want my turtle to disappear afterwards. So I'm going to say t.hide turtle. And what that will do is make my turtle disappear. So I will not see my turtle at the end of this. So here's my code, and I'm going to scroll down so you can see what's going to happen. I'm going to hit my run button, and you can see it tracing out my drawing, and then the turtle disappears at the end. And for comparison purposes, here's my drawing, and here's my original drawing. So you can see that they're very similar. But you'll notice a couple of glaring differences. One difference you'll see is that because this was almost like a signature, I dotted my I and crossed my T's in the original, and you don't necessarily see that in these illustrations. So that's probably the biggest thing that you notice, the biggest difference between what I've got here and what I've got in my original drawing. And that's why in our original drawing it was so important for it to kind of be one continuous stroke. And what I did, there was a couple of places where my pen lifted up off the paper. I just drew over it to make sure that it was one continuous stroke, with the exception of dotting my I's and crossing my T's. So at this point, we've written our program, we've got our output. Now we need to prepare our digital artifact. We need to prepare our document that we're going to give to our teacher. So I'm going to open a new tab. I'm going to go to my Google Drive, and I'm going to create a new Google Doc. And so here's my Google Doc. I'm going to call this Google Doc the Unit for Performance task. And I'm going to go to my Sculpt, and I'm going to select all of this by doing Control A and then right-clicking to copy. And I want to paste this in my Google Doc. So when I paste it, one thing I'll notice is that it's pasting it in the Arial font. And that's the default font for Google Docs, but it's not a fixed width font, and so this doesn't look like code. What I want to do is I actually want to change the font on this so this looks like code, and two really good choices would be Consolas or Courier New. If I select Consolas, you'll notice that this looks an awful lot like the code we were doing in Sculpt. They actually use the same font. If I were to select everything and to choose Courier New, then you'll see that this looks an awful lot like a typewriter font. So you can use whichever one you're comfortable with, but this is your performance task code. And then at the end, you're going to do your output. And to do our output, we're going to go back to our Sculpt page, make sure this is in the center of our page, and do Alt Print Screen. When I do Alt Print Screen, that actually copies it, and now I'm ready to paste it using Google Drawings. So I did New Google Drawings. Here's my Google drawing. I'm going to paste this, and then I'm going to crop it. So remember, we right-click and choose Crop Image. That brings up these black corners, which we can then move to the edges of our output. And now we can hit this crop icon, and now we can copy this and paste it into our Google Doc. And of course, I'll probably end up being on the next page, so I can go up here and hit Control Enter to make sure that my output, the word output, is actually on the page with the output. Now, this is the output of my program, but I also need to put my original on here. So I'm going to go back to my original and do the same idea, do Alt Print Screen to copy it. And I've scanned it using a scanner, but you could take a picture of it with your phone and then upload it. That would also be an option. Just email it to yourself. But that way I can paste it in here, and I can do the same idea of cropping it. And once I've cropped it, then we can, let's do the crop button. We'll right-click and copy this, and then we'll paste it in our original document. So notice that we'll be able to compare this, and by the way, you may want to change the size of this output because it may be a little small. Remember, you can do that by pulling on the corner of the image, and so now we can see how comparable they are. So the last thing we need to do here is we need to do a comparison. And here's where you're actually going to write a paragraph talking about how your output of your program and your original drawing were the same, talking about how your output and your original drawing were different, and maybe how to fix your program so that it's truer to your drawing. You're going to take about a paragraph to explain what you would do to either make your drawing truer or talk about how good your points really were. Keep in mind that the more points that you have, the truer to your drawing your graphics will be. Your program will do a much better job if you have more points. And you really should have at least 100 points collected in order to make this work correctly. So this is the idea for your Unit 4 performance task. Once again, this is Mr. Potter. Thank you for watching. Have a great day.